Assaf, I'm thrilled to host you for the second time and hopefully not the last time. Just for those of you who are not familiar with Assaf, Assaf has over a decade experience of building and leading AI products, and he's done some incredible things in the Gen AI space, which is why we have him here today. He's also held leadership positions in companies such as Wix and House, which I'm sure you're all familiar with, and together ramp up a valuation of over $10 billion. And aside from that, he's big on knowledge sharing. He's a prolific blog post writer, podcast interviewer, and he's even delivered courses on relatable topics such as Python at universities such as IDC. Now, our agenda for today, Assaf has prepared us through some very interesting deck detailing what he has done with GPT Researcher, specifically in the context of multi-agent architecture. Assaf, feel free to kick it off. Let's do this.
Great. So it's good to be here. Thank you, Jonathan, for the invitation. So I'm going to present a deck around, as Jonathan said, around 15 minutes. And I'm always happy to make it a conversation and not just a presentation. So I would also love not only questions from Jonathan, but basically any question from the crowd will be welcome. And let's just start. Share my screen.
Try to jump in, guys, with question. I'll be going over the Q&A, and I'll try to kind of take interesting questions and throw them into the talk.
That's great. So can you see my presentation?
Yes.
Great. So today we're going to talk about GPT Researcher, which is an open source that I've released to the world actually almost exactly a year ago. And through the open source, I will also discuss a bit about multi-agent frameworks and why I personally believe that they're the future and why I urge everyone to gain some knowledge in the space. So as Jonathan said, I will go through this very quickly. I'm the creator of GPT Researcher. I'm currently leading some Gen AI projects at Wix, reaching millions of users a day. This is something that many don't know about me, but before I went into the AI space, I was actually a musician, produced and released music album with a German label. Love sharing knowledge, been writing blogs for the past 10 years, and maybe most importantly, father to a beautiful young girl. So what is GPT Researcher? I'm assuming this crowd knows, doesn't know, but I'm assuming the least common denominator, and we will go into more advanced topics as the discussion continues. So GPT Researcher, in short, is an autonomous research agent that does online comprehensive research. I'm excited to see a great adoption by the industry with over 13,000 stars and growing daily. We have a community of 4,000 developers on Discord. And the one very interesting thing about GPT Researcher is that it can generate comprehensive reports of over 8 pages in under 2 minutes with a cost of less than a cent. And the reason why this is a very important line and why I want you to remember this throughout the presentation is because in the end, proper AI engineering is not just about showing great demos and videos. The challenges start when you look at costs, when you look at performance, and when you look at quality. And those are the 3 aspects that have really motivated me and the community over the last year to not just build a good research agent, but to build an agent that scales and has high quality and performance.
And by the way, I just want to put this for people into perspective. Some of the most widely used frameworks in LLM have an average of around 6,000 stars, and GPT Researcher already has double that amount and almost that amount in active developers using it. So this has a lot of impact.
Definitely. And I do want to shout out to the dev community because honestly, this is now a community project. This is something that we're building with a huge community. And obviously if there's any engineers or people who are interested in this space on this call, on this webinar, I would love you to ping me afterwards and see how you can contribute and we can collab. So I think the main question I get when I present GPT Researcher, and this is true today and also in the past, is why do we need GPT Researcher? I mean, we have ChatGPT, we have Perplexity, we have so many LLMs that connect with function calls to the internet. why do we need another agent that connects to the internet? And there's very good reasons why it's true today and why I believe it'll be true also in the future. Number one is that, as you know, LLMs are not connected or have outdated information. Secondly, LLMs are still surprisingly limited by the output tokens. So you can generate probably max, if you're really good at prompt engineering, you would extract around 1,000 words output from an LLM, but research reports can go all the way up to 2,000, 3,000, 4,000 words. And even if we say, okay, well, in 5 years, LLMs will generate that amount of content, you need control over just how much you need and how you can break that into more in-depth research. Another very important reason is that when you go under the hood of how Perplexity works and how ChatGPT works with web plugins and all the other alternatives, they actually do a pretty lousy job at data aggregation. You would imagine that there's a very complex RAG pipeline behind them, but there's actually a simple API call. In some best cases, they scrape some site content. And we all know that to do comprehensive research on tasks, you need to go much, much deeper than just a few search results. So I think those are the main, yeah, sorry.
Can you elaborate about that? Because I think most of the people on the call here are very familiar with the kind of known generative AI tech stack, where the building blocks are prompt engineering, RAG with the many varied techniques such as adaptive RAG and corrective RAG and stuff that's been coming out lately. Fine-tuning is thrown a lot into the conversation, but I think is rarely used. Where do agents fit into all of this? And what do you think are like the main things that agents are trying to solve?
So I mean, perplexity, agent is a very broad term. I think perplexity and ChatGPT are agents, basically. Agent is, to me, is a scoped business goal or a scoped task that is well defined. And the reason why scope is important is because agents should have a very defined finite scope of responsibilities and actions they can take. I think agents have the potential of automating a lot of what we do today, and we're seeing just the start of what they can do. And this is exactly why I'm excited about this project, is because it kind of demonstrates the next evolution of where we're seeing AI lead. So I will dive into this question more thoroughly throughout the presentation. Cool. So maybe I'll just do a very quick play of a demo. So if you download the project, it comes with a very simple UX UI. We have not invested in UX UI. We have no plans in investing in UX UI because the fundamental part is actually behind the scenes. It's the actual agent. But basically what you do is you ask for a research task. The researcher will then go and aggregate tens, if not hundreds of web sources, find and extract the most relevant content, and then it starts writing a very long research report. I'm going to skip this because I urge anyone to try this afterwards, but as you can see, it goes on and on and on. This is all in like 2 minutes. And then finally, the final output of a research report, you can download as a Word document, PDF. And here is an example of a result of just running this for a 2-minute run. You can just see how long the research is. This is a question about stocks to buy in 24. And as you can see, this is like a 10-page research report with tens of sources that it aggregated under 3 minutes in this case. So the thing that it's not only that it works well, but it's also important, at least one of the things I was considering when releasing this is, do I release this as a project, a Python library, or do I build a full stack application? Do I build this end to end? And I think this is one of the reasons why popularity soared, is because it is an end to end solution. It's not just thinking about how do you do a RAG pipeline, but it's how as a user who downloads this project, you can actually go all the way to using it as an end consumer. And I think that's very important in terms of adoption and in open source in general.
There's an interesting question that from the crowd. Is there a way to use GPT Researcher on private data? And a follow-up question is like, can they use it on premise?
Yeah, so the answer is yes. So the GPT Researcher supports both web sources and local data. You can see that. I would be happy to share afterwards documentation for how do you do that. Also, you can join the Discord channel and happy to answer that privately. By the way, since that question was raised, I have to say this. What we're seeing in terms of business use cases from enterprises using GPT Researcher is hybrid search, but not hybrid search as we know, where you use keyword search and semantic search. We're talking about hybrid search in the form of both web information and local information. So imagine that, and I think, Jonathan, you raised this earlier about corrective RAG. Corrective RAG is where you use web or local information to improve the planning of the RAG. So imagine a company for medicine who have patents about a specific medical, product, and they want to get a weekly update about any new regulations, patents, or things that can disrupt / compete with their product. They would drop into GPT Researcher local information about patents and descriptions and things that are not found in the internet. And then GPT Researcher can use that potentially to create a plan of doing online research around that topic on a weekly basis. And this is a very interesting concept that we're seeing a lot of big customers.
And if I could just mention like my own personal experience, because I think this framework has this duality that we see in a lot of very successful products, such as like Google Drive, where it's applicable both for your day-to-day use, and then it also has some very great enterprise use cases. Personally, some research that I've played around and done with the GPT research is I've tried to look how to invest into stocks. We all know what's happening with NVIDIA and everything. And personally, I have this, inherent belief about robotics due to have a ChatGPT moment sometime in the future, but I'm not an expert on the topic. And what I normally do is, scour the web, looking for information, reading through articles, seeing YouTubes. I have my ways of like accelerating. I have this, plugin which reads articles to me out loud. But still, every sort of research like this, which I do, I don't know, once every half a year, would take me a good solid weekend or two. I tried it with GPT Researcher, and it takes it down to like hours. Obviously, the result is much quicker than an hour, but then you have to figure out like reading through the PDFs, finding what's interesting, doing some follow-ups. At least a 10x improvement is what I'm trying to say.
Definitely, and we're actually learning that even if the quality of the content is not optimal, which this is also one of the reasons why we're continuing to invest in GPT researchers, because unlike other products, we believe that the more LLMs improve, it will actually improve the agent. Is that just having that list source in the end is already a great start for your own manual research. So even if you don't like the quality, just having that curated list of sources you might not even think about, or it could have taken you hours to find online, that's already value that our users find. So I will try to keep this high level. I'm assuming the crowd is somewhat technical, maybe somewhat not, but this is important just to understand, to give you a better intuition of the evolution of AI development over the last year, which was insanely fast. And secondly, improve your intuition later when we talk about multi-agents and what's the difference between this and multi-agents. So this architecture demonstrates the flow process that happens within the agent. And let's run it very quickly. So a research task comes in. The first thing that happens is that GPT Researcher dynamically generates a research agent for the given task. Now, why do we do that? We do that because we've learned that, as many of you know, prompt engineering is key for improving the quality of results. Generating a dynamic agent actually improves the final quality of the research report. So for example, if you're asking, hey, what are the top stocks to invest in 24? The first step would be to generate a prompt that describes an agent that is specialized in financial analysis. If you're asking about, hey, I need a 7-day plan to Paris, then it will generate a prompt that demonstrates an agent for travel. And just that itself already improved the overall quality. Once that agent is generated, the next step is actually generating a list of research queries that are different from the original task. And this is also key in order to find a more broad depth of online information, because not always does the user know how to write the best research task or query. And this also I find is something very valuable in terms of user experience. You should always assume that for many users, talking with AI agents is a fairly new experience, and you should not assume that they know how to optimize the way you know how to optimize. So always try to think about the ways you can take that original human input and expand it or improve it or refine it automatically in order to provide better results. So once, yeah, sorry.
And that's one of the things about agents, right? If when you're doing prompt engineering or you have just a linear chain, it's sort of like one shot, or you go through a chain and you're done. And with agents, you have this ability to have a loop where you can use for verifications. Can you elaborate on some of the things that you're doing there in order to address some known issues, such as one of the problems with agents is a lot of times they can just ramble and go on forever, and that escalates both the latency of the request and it also escalates the cost of the request because you're paying for more invocations, for more tokens and stuff like that. What are some stuff that you've done in order to mitigate that?
So first of all, almost everywhere I limit the amount of AI calls. It's almost never I trust the LLMs to do a perfect job. There's always a limit to how much calls every step of the flow can make. And then there's always a default. There's always a worst case scenario, always a worst case scenario defined. So for example, if we go back to the generate research agent, a default research agent exists. If you look into the open source code, you'll see that there is a definition of a default research agent. So in case of some confusion, hallucinations, etc., they will always fall back to that. The same goes with the research queries. Obviously, the fallback research query is the original research query in case of false or wrong outputs. So it's always about asking yourself, what is a good fallback, and how much really can I account for latency or retries? So I think that's also a very good question, Jonathan, important point. So I'll move forward. Once those research queries have been generated, we then trigger search queries with the search engine of your choice to get back various sites. As I said earlier, this goes anywhere from tens of sites to hundreds of sites, depending on the depth and customization that you as a user decides. And for every single one of those sites, we scrape those sites and retrieve all the content within the sites. Now, this itself is a headache, to be honest. What we find the developers love with GPT Researcher is that they don't have to deal with doing this manual process themselves. There's a lot of caveats to scraping sites. You have to do a lot of cleaning of the content. You have to know how to, for example, I don't know if you guys know this, but many sites, the content is actually presented with JavaScript. So you need to have JavaScript support to load the content. And if not, you would just find gibberish. So I think there's a lot of just scraping, and that's another part of the flow. And then once all this content is scraped, it's all saved as chunks into a vector DB. And then finally, after all that chunking is saved, we then retrieve the most top K relevant content using those generated research queries and generate a research report.
So one question that I would ask here from the audience, what does generate research agent mean? If you could just clarify.
Yeah. So I'll actually go into the code, but maybe it's best to keep this for curiosity afterwards. So there's a system message, right? When you have a system message when you use OpenAI, there's a system message where you define the agent goals, the agent, definitions, and then there's a user prompt where you actually ask what you want to do, right? So generating a research agent basically means generating that system prompt. You generate a system prompt specifically related to the original task, and that becomes the system prompt to all the future LLM calls that are made throughout the process. And as I said earlier, if you take, for example, having a system prompt, you are a research agent, your goal is to write comprehensive research reports, that could be a pretty good system prompt. But if let's say you want to do a report about travel, about, as I said, 7 days plan in Paris, there's very, very different. You should test this yourself if you want. Try doing a system prompt, a generic one, and then write me a 7-day plan for Paris and do the same thing, but the system message is, you are a travel agent. Your goal is to find the best ABCD for travel. You would see that the report quality is much higher.
And you're doing that dynamically, or you're working
Yes.
off prompt templates, or both?
Dynamically. We're actually sending an LLM call to generate a system prompt. And then we use that output for all the future system messages throughout the flow.
Great.
Great. So the reason why I'm showing this is this has been a continuous flow of improvements throughout the last year with the community. But most importantly, I want you to remember this too, is why and how this is different from the multi-agent architecture that we will now present. So I am very excited about multi-agent frameworks. I've been doing this at Wix for the past few years. Maybe I'll give you just an intuition to why even at Wix this is has such huge potential and huge problem. Wix is a company of thousands of developers, tens of various companies. And imagine that you want, as an enterprise, you want to build one chatbot experience. The Wix user comes in and can talk with one agent, right? You don't want to build tens of agents where every agent has different behaviors and different quality control. You want to have one agent that speaks with the user. But you can't have one team build this agent for everything at Wix, and you can't have tens of companies building together. That would be management hell. I would not sign up for that. So multi-agent frameworks allow you to achieve a separation of concerns where every company or every product at Wix can build their own specialized agent in a specific business domain. But in a high level, you have one system where you have one experience with the Wix users that can communicate with the various agents throughout Wix based on the user needs. And it's incredible to see it in production, and I highly encourage, as I said, many of, if not all of you, to spend some time learning this. This is definitely the next generation of LLM. We will see this in the coming years becoming the best practice for building AI systems. And I want to emphasize that with the evolution of LLMs throughout the last year. So for those who have been in this space long enough, which is only since, if I recall, 2020, when ChatGPT first released GPT-3 or GPT-2, the first thing that was obvious was zero few-shot prompts, right? We all learned that if I can provide some examples of how I expect the output, wow, this is genius, right? But then very quickly, LangChain came out and LlamaIndex came out and all these great open source projects came out that showed that you can achieve much more with LLM chains, basically very similar to what we've seen before with GPT Researcher. You have one LLM input, it outputs a result, that output goes into another LLM input, output, and so on until you reach a final result. And then function calls came out that allow LLMs to connect to APIs, which disrupted the entire quality of what you can do with LLMs, right? Because then you can do actions and you can retrieve information online or any other types of API functionality. And RAG pipelines are definitely here to stay, and they're still here. And then finally, multi-agents is the next part of the evolution. And if you don't believe me, then believe Andrew Ng, who recently was quoted that he believes that AI workflows will drive massive AI progress this year. And if it's not enough for me to urge you, then also Andrew Ng urges you to work in AI. And if you work in AI, please pay attention to it.
Can you explain a bit about like what agent workflow means? And like a lot of times it's also called workflow engineering in LangGraph, stuff like that. And maybe how you used it in GPT Researcher.
Yes. So I think the best will be to answer this in depth. I will answer it shortly, but we'll touch it more in depth in a few minutes when I show the architecture of the multi-agent system.
Then you can skip it for now and just touch it when you get to it.
Okay, so we'll touch it very soon. So again, very shortly, a multi-agent framework is designed to work with multiple autonomous agents, where the assumption is that every autonomous agent has a very specialized skill, right? So the best way to think of a multi-agent framework is that for the managers in the crowd, it's just about becoming the manager of a team of AI agents instead of working directly with one AI agent. You define and understand what different roles that are required to complete a complex task, and then you build a multi-agent framework system that allows for collaboration, distribution, decision-making of agents working together. Because I think the biggest challenges of going from one agent to a team of agents is how do they all collaborate? How do they communicate? How do they create synergy and they don't, do duplicate work or block each other or contradict each other? There's so many challenges in making this work. By the way, one of the biggest challenges is probability problem, right? So let's imagine that every agent in the flow has a 90% accuracy. If you look at it as a one specific agent in the flow, it's like, wow, 90% accuracy, that's amazing. But what actually happens is that if one agent calls the other, calls a third, the fourth, it's a 90% times 90% times 90%. Eventually, your output is a 70% accuracy. So there's a lot of challenges, and then there's latency. Every LLM takes around 5 seconds to return a response. The end user eventually will get an answer within 20 seconds. So there's all these big challenges in how do you build high-quality multi-agent frameworks, and we'll touch some of that very soon. But just before we show an example of how GPT Researcher implements multi-agents, I think it is worthwhile to get a glimpse of what exists today. There are various frameworks for multi-agents that already exist. We've got CrewAI, so the way I would suggest you to evaluate which one is right for you is if you're looking for very high-level abstractions of creating multi-agent systems that require mostly tools and prompts, CrewAI is the right solution for you. And generally, by the way, I think CrewAI is a great way a very soft way to jump into this ecosystem. If you're looking for something a bit more complex, something that can also be very well implemented as a production grade, then Autogen is a great solution, which is built by the Microsoft team. I personally love LangGraph. I'm also biased. I work a lot with Harrison and the LangChain team, but I also really believe that LangGraph is optimal for me because when you're very experienced in this space, you want full customizability. You want to be able to do as much engineering on your end, and LangGraph allows that. It's basically a stateful graph architecture, which we'll see in a second. MetaGPT is more focused on development lifecycle. So if you're building agents that are like, we need a product manager to work with an engineering agent that works with a data analyst agent, MetaGPT is a very good solution for that as well. And again, if you have any further questions, I would love to answer either now or in the end. But Jonathan, is there anything you'd like to ask?
I'm just going to say that we also have experience with at least 2.5 of these frameworks. We've looked at CrewAI and we have experience with LangGraph and Autogen. And I think they're each good in their own right. LangGraph obviously leverages off of the entire ecosystem of LangChain. And Autogen is heavily pushed by Microsoft, and it has a lot of value to offer. So I would at least suggest looking into these two when trying to develop a production solution.
100%. And again, I want to remind one thing. I think for those, again, who have been long enough in this space, you see how fast it's evolving. So imagine that where multi-agent frameworks are now is where RAG was a year ago. What we see now might be the first iteration of multi-agent frameworks. So maybe the one caveat I have for the crowd is we're all learning, we're all experimenting. What we see today might not be true in half a year, so just keep that in mind. And if you do choose to pick a specific framework and go with it, don't go all in and become blinded. Constantly look out for new innovation in the field, because that's just what it takes to be competitive today in this LLM space. So I want to touch, we're almost done, by the way. I want to touch about maybe the top reasons why I believe multi-agent frameworks are here to stay. And I also believe that this is almost the optimal scenario, where once it becomes commoditized as multi-agent frameworks, what we will then see is just LLMs becoming better and memory becoming better, planning becoming better, like all the different components of the multi-agent stack will become better, but this will become the standard. This is my bet for the next 5 years. And let's go over the reasons why. So first of all, separation of concerns, as I discussed earlier, also as an example of GPT Researcher, but also enterprise, separating this AI can become very complex. When you build a monolith of AI, it's almost becomes hell to debug and to understand where do I break. And we do iterations over entire AI workflow or AI chain, it just becomes almost impossible to improve it over time without breaking. And separation of concerns allows you to take specific roles and just focus on each and every one of them separately. So that's number one. Second is scalability. Once you have an agent team, you can easily add another agent as the service improves. You know what? You might learn that the agent that you're using today for research, there might be a new agent in the future that does a 10x better job. You just replace that with your current agent. So this is why it's also it makes so much sense that now when we see all these agent marketplaces and we see all this like specialized agents come out, it just makes sense that the next step would be that we could import those agents into our multi-agent system, which I'm also excited to see. And I know, by the way, that LangChain are already working in that direction and are going to release something very interesting soon about it. It's also related to modularity. So it's the same as separation of concerns. One thing that I'm also very bullish about is that it reflects real-world collaboration. So even just, so I spend a lot of time in design meetings, brainstorm meetings of how will this agent or how will this AI product look like? And when the discussion is around, let's just describe the roles. Let's describe as if we were building a team. We now want to build a new product, and we want to define what team do we need to accomplish this product? What are the different responsibilities? When the discussion is in that way, it becomes much more intuitive for humans. And this makes it much more easier to work with people that are not technical, right? What I just asked as examples are questions that any product manager, data analyst, and other stakeholders can easily contribute to, versus which LM should be used and which framework and how would the retrieval step work, right? Like it's a much better communication solution. Another important fact is that I believe as a manager that you always need to look at a team as the sum is greater than the parts, right? You always want to see that we are, and this is another very important aspect of multi-agent system is you want to show that when we work together as a group of agents, we're going to achieve a much better quality than the sum of the parts. And I can tell you already as a spoiler that the multi-agent has increased the quality of GPT Researcher by 30%. And we will see that in a second. Human AI collaboration, another very important point. When you have team members who are AI agents, adding human in the loop is just adding another node or another step that can oversee, can help planning, can do all these amazing things within the team. So that itself is also a very easy and scalable thing that you can add later on in your product.
So can we maybe stay a moment in this point? So specifically Jan LeCun, who what a lot of people must know, he leads the AI at Facebook. He's very much focused around the planning step. And he has this like very famous tweet where he says agency and planning, it can't just be a word on top of autoregressive LLMs. It must be an intrinsic property of the architecture. Now, there's a lot of research being done on the topic on planning and strategic planning. And I want to kind of hear from you where you started, what you found out, and how much emphasis is put right now on GPT Researcher in the planning phase.
Definitely. So first of all, I will take a step back from the question and say how much I am a believer of AI augmenting people, not replacing people. I can't stress it enough. I think it's true also in terms of philosophical reasons, but I think it's also true for optimal user experience. Humans do a great job in refining AI outputs, and as we see, as the next evolution, and we'll see that in a second, and what we see today with very successful AI products is the planning stage, as Jonathan said. Planning is about, before I start to create the process of using AI, let's first plan the steps, right? Let's plan the strategy of what we're going to accomplish into smaller steps that we can then execute in parallel. And having human in the loop in that stage is critical, because not only does it refine the quality, but it also optimizes for maximum user experience. And let's not forget this, because I can't stress this enough. In the end, we're building products for users, for humans. We're not building products for the fun of them. We're not building products because they're cool. We're building products to solve real business problems and real problems that users and humans have. And I don't know, Dana Ariely once proved that, he showed in the research, that when you give humans or users even a slight control or impact on the quality, for example, the Pillsbury experiment he did, right, where people just add that or put it in the oven or mix, and they think it actually tastes better than buying it from the shelf. The same thing I see goes with AI. When you put a human in the loop and have them feel a bit of control, or that they've contributed a bit to the process, the end result is going to be not 10, not 20, from what we've seen from various A/B tests. It goes all the way up to 50% improvement in user satisfaction.
I'll say from our perspective, where we work with a lot of customers on building custom solutions, going to production with a product in general, and specifically, let's say with a B2C product, is hard. Hallucinations are still very much an issue. And human in the loop is kind of this not entirely product way of solving things, but yes, it's a very easy fail-safe mechanism, which will both help you improve the model over time and will help you make colossal mistakes in production. Yes, it will obviously stop the flow. It won't make it real time. There are a lot of implications of putting human in the loop, especially where the frameworks stand right now. They're very much at the beginning of this, but it's an interesting place. And I'll second what you say. We spoke about this before the actual talk now, where you're a very big believer in human in the loop going forward. I very much agree with it. I think we're going to see a lot of investment in the near future and a lot of progress incorporating this, because if I have to simplify it, hallucinations are never going away. And on the other hand, the taste for automation is only getting accelerated, so we're not going to stop. And I think the middle ground between these two, like on the one hand, wanting to super automate everything with Gen AI, and on the other hand, not falling to the pitfall of hallucinations, human in the loop seems like a very, very good midway solution. Now, there's a question here which I want to bring up with Amitai Gilad asked, are multi-agent frameworks relevant for near online usage, such as Q&A, chat, in terms of performance? Assaf, do you want to take this first?
Yeah, I think it's a great question, and unfortunately, there's never a one right answer. But generally, I think it's over-engineering for Q&A. You could maybe use a multi-agent system to work as an automation and aggregates information to make it easier for a Q&A system to work. But we still find that for just simple Q&A, a basic RAG is usually a better approach, both for quality and latency. And for Q&A generally, I think it's a search problem. I mean, it's not an LLM problem. It's mostly a search problem where you have to invest a lot of your time in actually refining how you both save and retrieve the information that you're trying to answer about.
The way I see it is GPT Researcher is basically search on steroids, with the capabilities that it has, both of like leveraging in-house knowledge and the internet to a very wide extent, and You briefly touched upon this, and I have to reiterate this because we've done projects like scraping the web and stuff like that. It's not easy. It's a task that you're not like, oh, I have to get HTML. And Assaf said that it's also sometimes dynamically loaded with JavaScript. Like, let me just handle these two. You really far, far from the truth. And I'll say another two things. First of all, you said that like multi-agent architecture improved performance by 30%. So a lot of people might, rightfully also say, I mean, if you, developed this entire system over the last year and finally added like multi-agent and it added 30% in performance, like why don't I just start there? And I don't think that's the right approach. And we've spoken about this prior, and I think you share my opinion. You shouldn't start there. First of all, the frameworks, they're not easy to leverage. It's not easy to work. And a lot of the times the way to do this right, both in terms of having the right prompts and everything, it starts with straight up prompt engineering. You need to figure out the problem that you're trying to solve, and you need to start small and you need to start efficient. And you shouldn't throw the five kilo hammer at the problem because you're not going to understand it. Like you may hammer the first nail in because it is a 5 kilo hammer, but you're gonna miss a lot of stuff in the middle, and it's not a good way to learn, and it's also a very expensive way to learn. And and if I just touch on this like near real time issue in QA and chat, it's not going to work because I don't know what the average or the 95th percentile for GPT Researcher task, but agents very, very quickly get into the minutes of running a query or running through the entire pipe. And that just simply does not apply for like chat systems.
100%. I want to touch on 2 points, also back to human in the loop, but also agents. So maybe I'll start with the agents just to close that loop. The way I would start is define one agent and build it well. And that agent, for example, could be GPT Researcher. You will soon see the difference between GPT Researcher and the multi-agent framework system. But I would start at one agent under the understanding that this agent might become a few agents and it might become even tens of agents. So just keep that in mind when you start building, but start with one agent. Don't start because it has so much complexity. And around the human in the loop, another big reason why I believe it's a must is many for what Jonathan said, but I will extend on that and say that ironically, adding a human in the loop in the development of the AI application you're building will actually make you run faster and bring value to production faster. Because of what Jonathan said, when a human meets the output before it is either saved in the database or published to, for example, Wix, you can generate a site or you can generate content for your site. It never reaches production automatically before a user sees it. And having that human see it allows us to take higher and bigger risks. And being able to take risks with AI is a privilege, especially for enterprise. We've seen what happened with Google with their latest releases. They shifted production, they got killed, and then they're now behind Google because they can't take risks. So generally saying, always try to see how you can reduce those risks to move faster and disrupt and create innovation in the company, but always think about how humans can help you reach that. So I think it's another very important aspect. Just because we're running out of time, I will run to the last point, and that's a great starter for the last slide, is that multi-agent systems bring in a new and very disruptive technique, which is non-linear workflows. So when we look at chains and even RAG, I think that what is very obvious about those techniques is that it's a linear workflow, right? So you have one, as we said, you have input, output, then to the next LLM, input, output, the next. By the way, even having agents, go back to other agents, that's also considered linear. What is a non-linear workflow? It's the ability to have agents communicate dynamically between each other without knowing how much iterations they're going to do until they finally agree on an output. And this is the future of AI, right? Where it's not just me defining in advance, this is going to be the input, this is going to be the output, and I'm just going to refine to make sure the accuracy is high. This is pretty naive. I think where we're going to see disruption is where we actually trust AI to make decisions themselves by communicating with one another. And this is something that we see very nicely with multi-agent frameworks. And now finally to the architecture that we've released to the world around 2 months ago, which really went viral, really grown the community by 2 weeks since we released this. Let's just walk this flow together. So unlike the original architecture we saw, where it was basically a chain, what we see here is a definition of agents. We have the browser agent, which knows how to browse the internet. We have an editor, right? Editor is the one responsible of defining what is this research going to look like, what is the outline, what is the design of the research. Then we have the researcher, which, by the way, the researcher is GPT Researcher. This is, when we zoom out, GPT Researcher becomes one node. It becomes one agent within a much broader system now. It's not the entire system. It's one agent within a team of agents. And this is one thing I want you to remember, which is very exciting. Then we have the reviewer. The reviewer reviews the output of the research. It gives feedback. And then it passes the feedback to the reviser. The reviser, based on the feedback, can revise the research report. And then finally, once they make an agreement that it's now good enough, they pass all that to a writer, which gets all that information. It writes the final report, passes it to the publisher, which the publisher's only goal is, within a given report, I can publish this to many templates like PDF, documents, Markdown, and then finally it generates the final report. Back to that nonlinear workflow, the reviewer and the reviser can go on forever. I have not put in stop there. The reviewer looks at the research, passes the revision, it passes it back to the research, and they can go on for as many loops as possible. Now, obviously, this is a risk and needs to be managed correctly to make sure they don't go on forever. You can look in the code and see how we deal with that. But having that revision step and revise step, that's what increased the quality by 20%. And then having the separation of concerns where every agent is specialized increased it by another 10%. And that's what brought the overall 30% increase in quality.
Now, with all that good in it, monitoring and debugging, how do you handle that in such a complex system similar to this one? Do you even do it? I mean, sometimes it's a cost value kind of trade-off. There's always, I mean, just in systems that we've worked on, there's always more you can measure. There's always another way of looking at stuff, and you also don't want to over-engineer it. I see you're very much focused on like the performance in the system. So how do you gauge it initially? How do you make decisions? If you could elaborate on that a bit.
Yeah, so as we discussed earlier, multi-agent frameworks has its cons, right? We talked about how much it's amazing. We haven't talked enough about the disadvantages. And the disadvantages is by any means it's it's complex engineering. I think a best way to compare this to what exists today is microservices versus monolith, right? When you, as an engineer, decide what do I do? Do I build this a monolith or microservices? It's almost the same exact trade-offs. And how do you monitor microservices? You do micro monitoring. You have, for every single service, has its own monitoring. And your assumption is that by monitoring every single input output of a specific microservice, the sum of all those monitoring will give you good enough visibility to the as we said earlier, if every agent does 90%, you can assume the final output will be 70%. So when you start to look into micro agents, and we're going to make sure that each one of those are 98%, and we monitor that input and output over time and make sure that stays 98%, we can assume that the overall quality. So that's number one. And number two is, unfortunately, evaluation is still one of the hardest problems in AI. This is completely different, by the way, Jonathan, if you want to do a webinar about evaluation, I think that would be very valuable for many people. There's many techniques, many trade-offs. Manual evaluation is still the best way to evaluate. So I think that we use LangSmith, which is incorporated within LangGraph. as a way to debug the micro agents. You can debug and see the input outputs, what they do. That's a great way to debug the micro agents. And we do manual evaluation on the final output, which is basically looking at the final research report and just reading it and looking. I'll give you just one example because we're really almost out of time, but one example of a hard problem that we're now as a community solving with GPT Researcher. So we're doing parallelized work. Every research task is parallelized. It's happening in parallel. And then for each of those, a subsection report is written and then aggregated in the end. Now, what is the problem with that approach? That there's a lot of duplication of content. Every subsection can include content that was already defined in other areas, and it just becomes it just makes it more boring and just overwhelmed with irrelevant content. So this is things that you can only see when you look at them manually at the final research report. And I'm not going to go into the solutions that we're discussing. If you want, you can look into the discussions on Discord, but we're actually solving this problem right now.
So just to say to anybody who's here or has been following our community for quite a while, we have done a webinar on how to evaluate. Honestly, it was half a year ago, so we definitely need to update it because some of the things that we use today simply did not exist half a year ago. I would say for people focused on RAG, really look into RAGAS. It's a very simplistic frameworks. Shout out to the guys at Lang Talks who had an episode discussing RAGAS, so check them out as well. And I guess we're wrapping up things. And I want to end with the common question of what's your prediction for the future? Where do you go? Where do you see this going short term, midterm?
So I think I already spoiled that question by saying that I'm very bullish on multi-agents becoming the best standard. A lot like microservices has become Docker. We're going to see just like Docker was created and many solutions for making microservices better. Now we're going to start seeing over the next 2 or 3 years just a lot of infrastructure and better ways of just building those multi-agent systems. So that's number one. Number two, I think we're going to see much more user experiences happen around automation and moving away from co-pilot experiences where you just input, output, chat. I think the chat experience is not an optimal experience for all AI potential, and we're going to see a lot of automation happening and autonomous steps happening behind the scenes. So that's number two. And I think number three, obviously, is we're going to see LLMs improve much better in their capabilities of reasoning, which will probably eliminate a lot of the infrastructure and things that we have today. And then we're also going to see a lot of convergence into very specialized agents becoming one very good agent over a very broad task, which will also make multi-agent development easier.
I'll just follow up on that and give my own take. First of all, I think specialization is ripe. Investments have been made. The kind of flagpole has been set, and we're going to see specialization all over the place. The example I most like to give is the fintech industry. Always a very lucrative industry. We don't even yet have a consensus model which specializes around finance. And it's kind of an obvious, well-established go-to market when innovation waves come over the years, and we haven't seen that yet. As for agents, I've said this before. I obviously subscribe to Jan LeCun, and I think there's going to be a lot of focus on planning. I think there's going to be a translation of similar to what you said, a translation of reasoning an improvement and translation of reasoning capabilities into like decision frameworks for agents. Initially, that's probably going to be aided by human in the loop, which we've spoken quite a bit over the past hour. And last but not least, we're going to start seeing a lot of counterplay between agents in a multi-agent system. Right now, what people are doing is great, but it is mostly kind of this one agent which delegates work to all the others. And it's this kind of reciprocal down and up movement where there's one agent that plans and sends everybody to the task and then they come back. Where over the years, I imagine it being much more interplay than this back and forth motion.
By the way, for anyone looking to get better intuition into the various techniques of building multi-agent systems, I actually recommend Autogen. Just go into their documentation. and you'll see the pre-existing templates, all of the various techniques that they've found, which I think is very interesting to improve your intuition.
Great. Assaf and everybody who's joined, as always, I want to thank you. Me personally, I enjoyed this session. I enjoyed the content. I love what you're doing on GPT Researcher. Guys, if anybody has a topic in mind or wants to come talk about it and thinks the community will benefit, reach out to me either through the meetup or we have an email. It's jonathan@reachlatent.com. You can also find it on the website. If you like the video, please like, share, and subscribe. And we'll see you again in 2 weeks.